to the. Okay, so first, we are almost like near the end of our course, right? So যেটা idea ছিল যে you guys will present and that will be all, which is good, but we can also do something little more than just presenting. For example, যেটা অপু বলছিল যে plotting band structure, this is good. What if we also build a Python module that will do this work for us? Like, you present on your code or the process, also kind of build a repository in GitHub that we'll be able to use later on to do the plotting for our own kind of code, like as a module, like import that repository and we'll be able to use it, right? মানে জাস্ট প্রেজেন্টেশনের মধ্যে লিমিটেড থাকবে না আর কি, ফিউচারে আমরা ইউজ করতে পারবো চাইলে, প্লাস তোমরাও ইউজ করতে পারবা যার যখন প্রয়োজন। ইট উইল বি লাইক পাবলিক রিপোজিটরি। সো গিটহাব, আই থিঙ্ক আই আস্কড ইউ বিফোর বাট আই ডোন্ট রিমেম্বার, সবাই কি জানো যে হাউ টু ইউজ গিটহাব?
I've previously used GitHub, but I forgot.
ওকে,
আমি কখনো ইউজ করি নাই, জাস্ট মানে আমি কিছু রিপোজিটরি অ্যাক্সেস করছিলাম কিছু ফাইল ডাউনলোডের জন্য, এতটুকুই।
ওকে, ওকে,
বেসিক কিছু জানি স্যার।
okay, now that's, I mean, if you have kind of say, at least seen that the how the repository works like a little bit, then it's something. It's not too bad. Um,
So I have idea about that.
yes, question?
I said I have idea about that, how the repository works.
Yes, I mean, মানে যদি এরকম হয় যে you have somewhat used it, like browse করেছো or বিভিন্ন repository দেখেছো, or at least like something like this exists where you can upload your codes. That's also something. Now it's just like now's the chance to actually develop that skill a little bit and upload your, like, what do we do that মানে প্রেজেন্ট করলে, that's good. আমি চাচ্ছিলাম প্রেজেন্টের সাথে সাথে যদি এখানে করতে পারো, like if you present how to work, say work with the data, like you with using your own code or something, গিটহাবে তোমাদের ওই আইডিয়াটাই কাইন্ড অফ কোডের মাধ্যমে লাইক ট্রান্সলেট করে আপলোড যদি দিয়ে দাও, তাহলে এটা মানে ইটস লাইক ইউ প্রেজেন্ট হাউ টু ইউজ দিস থিং অ্যান্ড ইউ হ্যাভ দ্য কোড রিটেন ওভার দেয়ার, রাইট? মানে অ্যাকচুয়ালি ইউজ করা যাবে, আমরা সবাই ইউজ করতে পারবে। I have those codes, I mean a lot of codes written, so I mean এখনো রিপোজিটরি বিল্ড করি নাই, বাট it's possible that uh, that could be also be something like we can work on. Plus আরেকটা যে বলছিলাম যে getting the Hamiltonian, that can require some processing like in between or afterwards, so সেগুলো আমরা ওখানে আপলোড দিতে পারি। So let me share my screen. uh, uh, okay, so for the repository, what should be the name of the repository? I was thinking these two. Basically, we'll parse the quantum SML outputs and input files, um, prepare the data in a matching format in Materials Project API. Have you guys used this Material Project API? It's basically
Yes, sir.
But I've only
Yes, sir.
okay, that's good. Yeah, in Materials Project, you can uh, log in with your Google account or GitHub, for example. You can search any material, most likely it will be there. Say silicon example. If you search, okay, there are different material with IDs and crystal structure. You just open one and you go there to crystal structure. You see there lattice parameters, angles, and then symmetry information, and then electronic structure. You can also see the plot, right? So এটা Python API দিয়েও plot করা যায়, which is useful when you want to compare. Like you compute your band structure, visually compare করতে পারি মানে এই ওয়েবসাইটের সাথে যেটা আমরা আগে করেছি, or we can also compare by plotting them on top of each other, right? Which is useful when you are like trying to fine tune your um, computation. I think I have shown in class that what is it? Let me go there, and Metros project, for example, yeah, here. So this is something I have been working on. So here the red line that you see, solid red lines, that's the Metros project data, and the dashed line is the computed band structure using Quantum Espresso. And so they're almost lining up nicely, right? So if you can plot them like on top of each other, then you can actually see how good your uh, computations are compared to Metros project. Metros projected যে band structure আছে or density of states, it does like they're not necessarily the most accurate one, but it's somewhat accurate that everyone uses it more or less, but you can do more accurate computation. Eh, Accurate means suitable to your system, kind of fine-tuned to your system. Which one is like the actual band structure, like 100%? I don't know if anyone knows. It's just approximation. Okay, so this is something we can do using create a repository and then do all this. Uh, or okay, so that's the idea. What do you think about this idea? You don't have to work a lot. Just simple things. Maybe you write few functions, 2, 3 functions, and that's all. Hello, my audible?
Yeah. Yes, sir, you're audible. No, sir, the idea sounds great.
Okay.
And I think it would be easy to implement also.
Yeah.
Sir, I never use the API. Like, can you explain it a bit? Like, I accessed the website and like saw what was there. That's it.
Okay. Yeah, that's the
Uh,
plan for today's session actually. I wanted to show you how to use the API and kind of how to plot on top of each other. As I told you, I already have some code, but as always, you can always improve your code, right? So I need help from you to kind of modify, improve, and add stuff there. So so yeah, think about the names. Do you think I should create a poll in the Discord, or I mean, between these 3 names or 4 names, DFT Viz, DFT Kit, DFT Tools, QE Analyzer, which one sounds better? I mean, these two are kind of more general. Initially, we can start with like what we have, the ideas, but in future we can add more stuff there. But if we do DFT Viz, it's mostly visualization, like the name suggests, it's visualization. Um, So if you have, some kind of new ideas for names of the repository, because I feel like it's possible that people will use this repository because the existing tools that I have found, they're okay, but not the way I want. Like the most, say, the way Materials Project API works, those tools aren't really, I couldn't make them work in the same way, simply. So I want to kind of build a repository that will do that work, and the data structure would be similar to what we have in Materials Project API that I'm going to show you now. So I need names, like which one to use. Okay, let me show you how to use what is this Materials Project API. So I have this file in, you know, uh, Jupyter notebook format. Okay. All right, I think this is probably fine. So, okay, so to access the Materials Project API, you need an API key. Okay, so if you go to Materials Project and click API, then you have an API key, right? Like this, simple. This is my key. And when you create your own account, you're going to have another key. Yeah, I'm going to talk about this error afterwards. Um, so what I have done, instead of having the key as a string here, I have the API key written in a file. And on this block, I'm just reading the file and saving the key to this API underscore key variable. The reason for doing this is I don't want to upload my API key in any format to GitHub, right? Because that's like access to my account in some sense. So that's why it is done this way. I don't upload this API key file. I just upload this compare dft.ipynb file. Um, so here I have this API key as a file. My key is saved there as like a single line, single string. Okay, so, and when you have that key, you can just do, import this MP API is the Materials Project API, MP, Materials Project API. API means, I think, Application Program Interface. It's just a way for the user to use those codes, in a nicer way. Instead of getting into a lot of details, you just call the functions and get the work done. So you need to import this MPR, MPR star, MPR star, and for each material, you have this materials ID. For example, for silicon, the ID is MP149, this particular silicon. Space group is this one, there's the band gap. So if you use this code, MP149, then that the data you'll get will be for that particular material with that structure. Okay. So, and with you can access the materials project database using your API key and get the material structure, band structure, density of states, and sometimes some summary and other documentation if when needed. You can get a lot of things. So I'm just gonna load it, like everything. Okay, I think I'm done. Yeah. Then let's just print this. So when you print, these information like summary or docs, you can see a lot of details there. For example, um, this is the materials project, material ID for that material. It seems there are other IDs. I don't know why, but it's formatted the same way, MP dash a number. And here, this is basically uh, how they have computed that material. For example, we have MP914 and which is different from this ID, right? But this 914 just means that it's it's the same material, but it's just computed in a different way. Like every time they do for the same material, if they do computation in a different way, they use different ID. For example, this one is this. So this ID represents GGA static approximation. That's the calculation type. And that ID is for GGA NSCF line. GGA means, I think, uh, general gradient approximation, or uh, I don't remember, something like that. Uh, so yeah, like when you compute, you can use different pseudo potential, right? And different pseudo potential corresponds to some different approximation. So that's what it means here with different ID. And which one do you want? You can choose. By default, it just loads the one in the graph you can see here. Okay. And then you can also see the structure. This structure is important. Okay, I have a question, I think. Generalized gradient approximation. Yes, it's not general gradient, generalized. Thank you. Uh, so here you have the structure, and if you remember, uh, no, it just, can I open a new window? Okay, let me go here. If you remember, in our computation, we need to provide their cell parameters, they're the lattice vectors, and atomic positions, right? And if you know the Metros project ID, MPID, you can get the cell parameter, capital ABC, and the atomic positions, like the atomic position and cell parameters they have used in their computation. This could be your initial input in the SCF file, right? So one question is, how do we create the SCF file? You can create it this way. Take some information from materials project and create initial structure, do some optimization on those variables, like rho cutoff energy and wave function cutoff energy. And then, you go from there. Like this could be your initial input, right? From the structure information. Okay, and they also provide this, branch information, meaning in their data from index 0 to 38, that's the path along gamma m. If you remember, uh, Brion zone cube, uh, probably, yeah, this is the documentation you've seen. So if you remember, here we had different paths, right, in Brion zone for hexagonal system. So that's gamma, that's m. So along that direction is the gamma m. And here it says along gamma m, the data from 0 to 38 is along that direction, right? So it's like, you can have this information is sometimes useful when you are interested in a particular, direction, a particular k path, right? And that's the information you provide in, let me, uh, bands dot in DOS bands, yes, post processing, no, what is the input file? Just a minute. Input file, yep, here you see, uh, crystal, in the bands computation, bands dot input file, k point crystal B, here I have gamma m like this from gamma to m point, and That's the one, 0 to 39. So exactly what you provide here, like first 39 data points would be along gamma to m. Here, from 0 to 38, that's 39 of them is along gamma to m, right? It's like, so we also have this information written in some input files or output files, and we just need to extract it. In Metro's project API, they have already that in this structure, start index, end index, gamma to m. So, uh, it's useful if we have this divided or some index information so that if you want to plot along a particular path, you can easily do it. You have the index information. And then another important thing is calculating the mesh size. Why this is important? Because it's possible that in the Brimon zone, the length along x-axis or kx is different from the length along ky, is different from length along kz. But when we compute, we want uniform grid along all direction. And for to do that, we need to have if kz is longer than kx, then along kz you would need more grid points so that the distance between consecutive grid point is the same along all directions. Does it make sense somewhat?
Yes.
Okay, this is really important because the material that I was working, uh, so I wanted delta K to be 0.08 inverse Armstrong, and using this formula, I see that the mesh 9924 would create that mesh along KX and KY 9 grid point, along KZ 24. It's like more than double. Okay. So this is important that you kind of do this estimation before you actually compute anything. And I have here 12, 12, 24. Along KZ, I have more points. There's a reason for that. The reason is KZ is longer. We want, longer than KX and KY for my material. Okay. And then you can find atomic masses, which is 92 and 32. Used here, 92 and 32, right? These are the initial kind of data that you want to use. And in Metro's project API, they have used 92.906, 32.065. You can also get the cell parameters. So these pieces of code, they're like just extracting this information. So the API that we probably will be building, we also want these pieces of code there so that if the command is create a skeleton SCF file using Metro's project information for a particular material, we should be able to create a file like this using Python, right? Some information would be same, some would be different. For example, we can get atomic mass, cell parameters, atomic position. Also, we can compute the approximate K points, right? We just create this input file. That will make task easier for us. Like when I created that in this input file, I think I manually copied all this, which is fine, but you can also automate the process that you give the initial, like some information, it will spit out the output, output as an input file for for this SCF computation. You can also get the atomic position in this format, and this file I have here is in pickle format. So when I extracted the data with the help of another student that worked in our lab for over the summer, yeah, we worked on like how to get the some information from the outputs of the quantum espresso computation. So the file is in pickle format. The idea here is that all the outputs, like the K points and the band path, the atomic position, all the important information that one might need, we extract it from input and output files for quantum espresso computation, and then save it as a pickle file, which is kind of a compressed data file. And then we just plot the bands here. I'm not going to run this cell, but I can run the cell, yeah, this one. So, okay, QE NB3S4 run 7. If I just load that and do some cleaning, cleanup is important. Those are little details, because sometimes there are like extra branch information that we don't actually want. So we need to get rid of those. And you see, okay, I was, okay. So see, this information, name, start index, end index, is similar to the one we have just seen before, right? A little earlier. In Metro's project, we have this start index, end index along different path. And this one, this branches information was created by us. What we extracted previously. And after that, we have all the keys, K points, bands, Fermi energy, density of state, and a few other things. And here we can plot, and we see that, okay, why is it like this? Okay, I understand. Because our, yep. So there are some issues, some mismatch somewhere. So we may need to fix those at some point. So this is what it looks like. Um, when you plot on top of each other, and I think if I do 1.06, will it look better? Nope. 006, or just exactly, meaning sometimes the Fermi energy is not exactly right, so you need to tune it somewhat little bit. It just shift along vertical axis. But you see here I have along gamma M, M, K, K, gamma, gamma A. So the way it's in here in Metro's project website, gamma X for silicon, X to W, W to K, right? And if you have it along, like if you want to plot all the K path along in the Brillouin zone in one plot in a 2D, right? So that you can see what's going on in a 2D picture. To do that, we actually need those branch information. And you see along gamma A, the distance is longer, along MK is shorter, which is important. You see here as well, right? Along gamma X is longer, along XW is shorter. So while computing, we had more grid point along gamma X, less grid point along XW, if you compare these two, right? And the reason is what I told you, we want uniform grid along all directions. And to have this different length in matplotlib, we have something called width ratios. And when you set up the plot, you can set up this grid spec KW key with the width ratios. Okay, so number of branches I have must match this width ratio. You must provide width ratio for all the branches. And then you have this plot. Okay. And we can also plot the density of state, which is here. To plot density of state, you need DOS plotter. Uh, BS plotter is the way to plot band structure using Metro's project API. DOS plotter is to plot the density of states. So this is DOS, and if you remember, we extracted DOS like this, in this way from Metro's project, and here we're gonna plot it here. And let me comment my data for now. So that's the DOS in Metro's project, and we have just plotted in here. And you can also plot, you know, a band structure and density of state side by side in Python. And I think I have it here. This is the bands. You can plot the Brillouin zone, the density of state, also plot them side by side, right? And all this color shading, the formatting is kind of automated. You just need you know uh, BS DOS plotter. BS means band structure, DOS means density of state plotter. You set this up in this way, these projections, and get plot. You provide the band structure and density of states that you get from Metro's project, and it plots this nice plot for you, right? So yeah, that's it. So um, so the workflow is, first, to get started, you need atomic position lattice parameters, and uh, what else? The mesh information, those things, few things you can get from Metro's project API. Then you create the input file, run some optimization. I think I have probably shown in class that if you run optimization, for example, the cutoff energy, it looks like this. Meaning, if the cutoff energy is 50 or above, the total energy is in the stable, or it reaches the equilibrium or constant. If it's like 50 or 60 or above, you can do 70, 80, but that's going to take more resource and more compute time. So you want minimum of all these that gives you kind of a stable result, like good result. You can also optimize the row. After doing all those parameter optimization, you run final SCF computation, then NSCF, then the band structure and density of states computation post-processing. You get all those DAT files, bands.dat and density of states.dat, DOS, where is it? Yeah, DOS.dat DAT file, and all the output files from the computation. And then you extract all those, get the branch information, and plot Metro's project data and your computed bands to compare how good it is, right? That's more or less the workflow. And in between, you have to kind of do a lot of testing, optimization, a lot of things. Yeah, that's it, more or less. So getting this branch information and plotting is something kind of extracting this data is sometimes a little challenging. For example, if you go there, bands.dat, the file looks like this. So first line is just the like what it is. N band 100, meaning I have 100 bands there, because if you go to the STF file, you see N band 100. So I have 100 bands. And I have 499 K point in total. So, and then second line, that's the K point, 000, that's the gamma point. If you remember from the plot, that's the gamma, the starting point. And line 3 to line 12 are all the energies for those bands at that K point. So if you go to this corner, all these uh, dots, the black dots along that line, those are the energies given here, right? And then line 13 is another K point, and then you have energies for that K point. So uh, you need to kind of extract this K point information and bands from this bands.dat file. Okay, try to work on your own code. I think I have like somewhat code written. I'll probably create the GitHub repository, and if you don't have an account, try to create an account. So this is my account, SIJ314, and I have some code written, I think here probably. Data parser, data parser new. Those are written by Daniel. This is his account. Um, we did some kind of work together over the summer, and probably he will be contributing as well, but we can go from there. Like we have some initial work that will help us um, like make more progress. So yeah, try to create a repository so that I can add you as a collaborator maybe. Um, more or less, I guess that's it for today. Now, do you guys have any questions?
স্যার একটা
স্যার
কোয়েশ্চেন
Um, yes, one by one, please.
আচ্ছা মানে আমার তো জাস্ট ছোট্ট একটা কোয়েশ্চেন মানে এপিআই মানে এখানে তো যেটা বলছেন সেটা মোটামুটি পুরাই বুঝছি বাট মানে আমার কোয়েশ্চেনটা হচ্ছে যে লাইক মানে এপিআই ব্যাপারটা কি এরকম যে এটা একটা লাইব্রেরি হতে পারতো জাস্ট মানে আমরা লাইব্রেরি যেরকম ইনস্টল করি শুরুতে যেমন ম্যাটপ্লটলিব বা এরকম সো এইগুলা জাস্ট হয়তো কম স্ট্যান্ডার্ড দেখে সেটা লাইব্রেরি না হয়ে প্যাকেজ এপিআই আকারে আনতেছি এরকম
Uh, well, I think they're just different names, but technical definition is a little complicated. Like which one you call module, which one is API, which one is library. But to me, they're just different names of the same thing.
না
Something that
মানে
you can install and you can import and then you can use,
এটা মানে ইট ফেল্ট লাইক দ্য সেম থিং এর জন্য
right? No, I
থ্যাংক
mean
ইউ
the developers they will know like the difference. For example, when you talk about say functions, for a physics is one thing. Like you have an input, you get an output, for example. But if you go to a mathematician, they have terms, like specific terms for like what is a function and how do you define the function. A function is a map that takes you from Rn to Rm, one space to another. Like is it in defined in manifold or what kind of space is it? Like that can get more technical in their field, but to us it's just something that you can import and use, I guess. So it's like a heads up. If you ever talk to some real developer, they will you want to be careful about the terms because otherwise they will confuse like what you're trying to say. Okay,
আই আন্ডারস্ট্যান্ড ইট থ্যাংক ইউ
no problem. Yes, another I had think maybe Oppo had another question.
স্যার
Yes.
স্যার আমি একটা পেপার পড়তেছিলাম স্যার, তো পেপারে একটা কনসেপ্ট হচ্ছে ডেনসিটি অফ স্টেটের সুডো গ্যাপ। অ্যাকচুয়ালি আমি বুঝতেছিলাম না যে টপোলজিক্যাল ইনসুলেটরের জন্য
Okay.
বলতেছে যে ক্লিয়ার ডেফিনিশন পাই নাই, বাট মিন করছে এরকম যে স্যার, যে ফার্মি লেভেলের পাশে যদি কোনো ডিপ থাকে তাহলে আমরা এটা সুডো গ্যাপ বলতেছি। মানে এক্স্যাক্টলি সুডো গ্যাপ মিনিংটা কি আসলে, মানে আমি বুঝতে চাচ্ছিলাম, আপনি
Pseudo
জানলে যদি
gap,
বলেন।
a deep near Fermi
জি
level.
স্যার।
Uh,
জি স্যার।
okay. So, okay, what's the idea? Idea is if a band crosses the Fermi level, that's the metal. And if there's no band is crossing the Fermi level, that's probably semiconductor, insulator, or something else. And in the density of states, if you have some finite DOS um, on the Fermi level or near Fermi level, that's gonna be metallic. That's the indication of metallic properties. And meaning, so when you compute the say resistivity, you need to do an integration.
স্যার
And
বাফারিং হচ্ছে কথা শোনা।
um, I okay, so
বাফারিং আমার এন্ডে হয়েছিল।
I don't know. I got a notification that your internet connection is unstable, which is unlikely, but I don't know why. Okay, so আবার বলছি তাহলে um, so what happens near the Fermi level is important. And density of states, if you have finite value of density of states at the Fermi level, that's an indication it's a metal. কিন্তু it's more or less like a distribution, like what happens around the Fermi level. So, like if it's the band and it's crossing the Fermi level, um, just to show you the graph. Uh, okay, let's do this one. If it's a band that crosses the Fermi level, then that's the metal. If it doesn't, then that can be insulator or semiconductor. Um, okay, but density of state is more like a distribution. It's not a single line crossing, right? So if there's a dip, meaning the contribution from the bands that crossing the Fermi level is less, and the contribution from the bands that aren't crossing near the Fermi level, they are probably more in that, for in that region, in that energy range, I think. So if a dip would mean it's more like an insulator in that energy range than like a conductor. And when you integrate to get the resistivity, for example, there's an expression. Let me resistivity using Boltzmann transport equation. Let's see if I can get the. I think if I show you the expression, you'll probably know. Or uh, uh, I had the. Okay, what is it? Session time. Okay, Bootstrap 2 documentation. What is the paper? README theoretical brief. Yep. And Lorentz number. Oh, wait a minute. This is logged. I think I have this paper. Let me Zotero. I think I need to show you the Seebeck effect. No, not this. No. Where is it? Hmm. Uh, okay.
স্যার স্পটলাইটে অথরের নাম দিয়ে সার্চ করতে পারেন।
Spotlight. Yeah, that could work. Wait a minute. Where did it go? Wang. Uh, no, that's the other paper. And nope, I'm not getting it. I don't know. It must be somewhere. So, but I need to show you the expression. Let's see if I can. Wait a minute. I can share my. I can just try to write down the equation, like the basic. Let me join from my iPad. Zoom. Uh, Join 923. I can switch. Now, if I switch, it will stop the recording. Join. Uh, 92320.
Recording in progress.
Okay. I can show you the screen. Start broadcast. Okay. So these transport quantities are like this. You have say rho, and you have an integration, and in that integration you have del F over del T. F is the Fermi distribution, which is I remember the graph. So this is temperature. That's F, and this is the Fermi temperature. So it's like this, right? And its derivative, dF over dt, is like this. Okay. And you also have the density of states, d, say E of t, and some other function, and then temperature, for example, dt. So when you or maybe dE, I don't remember. Okay, something, some of them are dt, some of them are dE, I don't fully remember. But the idea is you have the uh, bands, density of states, or dE, I think as a function of E, all of them. Okay, so there, that's your Fermi level, and the density of states are like this, for example. And when you integrate, what you're doing, you are taking product of this derivative and the density of states. And there could be some other function, but that's not important. Important things are this: derivative of the Fermi function and the density of states. You take a product. So what happens at a particular temperature, you basically, have like this. That means when you take the product of this green and blue line, df over dt, there's a peak at the Fermi level, right? So what happens in this region are important. This big peak that's far away from Fermi level is not going to contribute to the resistivity if you do this integration. Does it make sense? It's like the delta, direct delta function. So
Yes, sir.
if we have f of e, delta of e minus ef dE, do the integration, you're just going to get a value of that function at this energy, right? Like the Dirac delta. So at different temperatures, the width of this df dt changes. At low temperature, it's like a sharp peak. At high temperature, it's like a little wider. So at high temperature, it could be like this. So what happens here is important, not anywhere else. So if there's a dip um, in the density of states, if there's a dip here, for example, dip means like this. Okay, so when you're doing the integration, then that dip is like df dt is non-zero there, right? But the dip is kind of giving you zero overall, less contribution. Does it make sense? When you take a product of two functions, one of them is zero, you're not getting contribution for that portion. Does it make sense somewhat?
Yes, sir.
I think it's
I
something
can
like
understand.
that. So try to find out the expression for rho or the kappa thermal conductivity using that uses the Boltzmann transport equation. Like you have an expression like this. You have this derivative, you have this density of states, and maybe some other things over there. Maybe you have E minus EF. I don't remember, but something. But that's the idea, right? Idea of getting the transport. Um, I think this is what they meant. Like if there's a dip, that's not gonna contribute much. So it's like like an insulator maybe at that temperature or something. Yeah. Maybe this somewhat answers the question. I am not sure.
স্যার মানে পেপারটাতে বলছিল স্যার এরকম যে ফার্মি লেভেলের পাশে যদি ডিপ থাকে তাহলে সেটা এই সুপার কন্ডাক্টিং মেটেরিয়াল টাইপ কিছু বলছিল। এক্স্যাক্টলি
Superconducting.
আমি পেপারটা খুঁজতেছি। জি স্যার।
Yeah, maybe you can send me the paper. I can take a look.
জি স্যার, এস না দিস পেপার আমি স্যার খুঁজে আপনাকে পাঠিয়ে দিচ্ছি আমি।
Okay, yeah, okay. Yeah, superconductivity is something um, little advanced because on top of having the bands, you also need kind of other interactions like those quasi particles, like formation of electron-electron pair, the Cooper pair for if you talk about BCS theory. Okay, maybe I can exit, stop share, leave. All right, so now let's talk about this problem. Do you guys have any other questions? If not, we can try to solve this technical issue now. Okay, so it says that you have the PW.X has stopped unexpectedly. Okay.
Sir, we can't see your screen.
Oh, sorry. Forgot to reshare. Can you see now the screen?
Yes, it's visible now.
Okay, so here it says that the application PW.X has stopped unexpectedly. This is from Alvi. So
Yes,
I have
sir.
a question. So do you get this error as soon as you run the code or after 10 minutes or something?
As soon as I start the code running.
Okay, that means there is something wrong with the input file. It could mean.
I'm using the input file that I have downloaded from your GitHub repository.
Okay, can
Previously, I
you?
used mine, but later, with the help of Okubai, I got into the repository of yours and downloaded the file. I can share the screen if you want. I can show you
Yeah,
the
please
save file.
share the screen. Let me stop sharing and allow other people to share. Allow, yes.
Can you see my screen?
Yes, I can.
This was the save file I downloaded.
SCF. Okay, can you delete that sudo underscore dir line?
This one.
Do you have sudo potential in that folder?
Yes, I think I've changed it here.
Okay, you have silicon, then that should work.
Let me try running that again.
Oh, why do you have that angle bracket there? So the
This one?
format is mpi run space dash np space instead of 4 do 1. Because remember we are using GPU, right? When you use GPU, NP should be 1 for a single GPU. If you have 2 GPU, you can do NP2. And okay, and then delete the angle bracket before the SCF file name. And afterwards, you just make it, delete that angle bracket and after a space, draw, have that angle bracket again. Like that's how you direct the output to a file. Add a space. No, একটা space দিয়ে, yeah, like that. So this will run the SCF file and output everything to scf.out file. Press enter.
I think it's running actually.
It's running, yes. So you had the wrong format. Okay.
And the
স্যার
beginning
এখানে
default.
Yes, question.
স্যার এখানে এনপি এর পরে ওয়ান যেটা এটা বলতেছেন যে একটা জিপিইউ আছে, মানে
Yes,
জাস্ট আমার
this
সিস্টেমে
is
একটা জিপিইউ
important
আছে
because
তাই।
if you do NP2, the way it's configured, it will try to run 2 instances in like single GPU, and that may not be kind of overall optimized. Like,
I have a question regarding this. Does MPI run refers to the GPU? I thought it rather refers to the threads of my
Yes,
processor.
number of process, কিন্তু these are tied to a GPU as well. So
I
it's
see.
মানে যতটুকু গুগল করলাম দেখলাম যে for if you have a GPU, then this NPI number of ranks should match the number of GPU. Since I have one GPU, it should be one. I tried
I
to run
understand.
two, but I didn't see any kind of good progress or anything. So
স্যার
one
আমার
thing
কাছে
is,
হচ্ছে রান করছিল 2 বা এরকম কোন একটা নাম্বার, কিন্তু মানে যেটা বলেন মানে কোনো ডিফারেন্স পাই না। সো আই থট যে হোয়াট এভার সিস্টেম হার্ডওয়্যার আই হ্যাভ ইট জাস্ট ডিভাইডস ইট ইনটু টু সাইমালটেনিয়াস প্রসেসেস অর সামথিং লাইক দ্যাট।
yes, NP divides into different CPU processes. কিন্তু single CPU process is, I think, tied to a single GPU. So দুইটা CPU process আছে, but you have single GPU. Overall, you should probably won't get any performance boost, maybe. It's
I
like how
understood
you
that.
configure your system. But if you do phonon computation, uh, like some computation can be parallelized and that will use GPU, but some computation are kind of serial computation, like CPU based. সেই ক্ষেত্রে GPU configuration turn off করে if you can use only CPU might be overall, faster. Like you kind of need to know, what kind of way is getting, the way of computation. Is it parallelized or using serial mode? For PW.X, it's mostly, parallelized, so you can use GPU and CPU, but single thread is or single core is tied to a single GPU, so use NP1. Okay, like in my server. But if you use your own computer, say without any GPU, for example, or say your software is installed in a way that will only use the CPU, then you can use a number of cores available for -NP field. Does it make sense?
Yes, it
Yes,
does.
Okay, so this is your running in your own computer, this command.
Yes, sir. Another
So
thing, I was having issues connecting to the server. Can we solve it now?
yes, we can, but
Possible.
just 1 minute. So you have 6 thread or 6 core. This is
Yes, sir.
VirtualBox, right?
6 threads are assigned to the virtual box.
6 threads. So it's possible that uh, like in modern times, CPUs often have, say, 10 cores, 20 threads. So when you assign 6 threads, it's basically 3 core, 6 thread. So in that case, for your system, you can do -NP3, I think, because
I
you
also think so.
use CPU. Like you can Google this little bit, like how to configure this -NP, like for a particular.
Previously, I've used LAMPS for molecular dynamics simulations. I used to do this run, the MPI run, with number of processor like 4 to 6 in this PC. While the LAMPS didn't need virtual machine,
Okay.
but without the virtual machine in Windows, my PC has the specs of 6 core and 12 threads, where I used to run LAMPS with MPI run using number of processor about, I think, 4 to 8 each time. I think it might work if I change it to 3 or 4, since I've
Yeah,
assigned 6 threads here.
6 threads, so I think you can safely use 3, but if you want to use more, I'm not sure, because like it's kind of depends on the system, right? But yeah, you can explore a little bit. But now maybe we can talk about the problem of connecting to the server or something like that.
For now, should I stop the run? How do I
Yeah,
stop the run?
probably you can, yeah. Let's try to solve the issue to connect to the server.
he's asking how to interfere and stop it.
Control C, go to terminal, press enter, yeah, that should stop. If that doesn't stop, there are other commands that you use a different.
Stop
You can-
actually.
Okay, good. you can open a different terminal and kill that process manually using super user privilege sometimes. Um, in Linux, you
স্যার
have, yes,
আমি যদি টার্মিনালের পুরো উইন্ডোটাই অফ করে দেই তাহলে সেটাও কি প্রসেস স্টপ হবে না
that should
প্রসেস
cross
ব্যাকগ্রাউন্ডে
all
চলবে?
the concept is like this. You have a main process, you have sub process. Terminal is the main process. If you close that, it should kill all the sub process unless you run those sub processes using some kind of it's not the correct term, let's say headless mode, meaning if you run the sub process so that they can run independently, in that case, closing the terminal may not close the sub processes. It's possible to do that. And sometimes you might want to do that. For example, যদি সার্ভারে কোনো কোড রান করো that will take say 3 hours or 5 hours, for example, is you might want to close your terminal and have it in a way so that if there's interference in the connection, the process doesn't get interrupted. Does it make sense?
ইয়েস ইয়েস
So ওই ক্ষেত্রে তুমি
মানে
সাব প্রসেসগুলি ইন্ডিপেন্ডেন্টলি রান করতে চাবা. That's
হুম।
kind of something you'd want. Yes.
আমাদের
Yes.
আমাদের সার্ভারের সাথে যে কানেকশন এসএসএইচ দিয়ে কারেন্টলি যেটা
Yep.
ওইটাতে আমরা যদি টার্মিনাল অফ করে দিই তাহলে কি প্রসেসটা ওই সার্ভারে চলতে থাকবে না?
No.
ও
You
আচ্ছা
need to run the command in that way so that it keeps running in
ওকে
the server. So the way to do this is after your command, add a space, then add a ampersand character, and character, single and,
ইয়েস
before pressing enter. If you do that, that should run the process independently and should run even if you close the terminal.
থ্যাংক ইউ দ্যাটস অ্যাকচুয়ালি ভেরি ইউজফুল
You're welcome.
Uh,
Uh,
this is what I'm facing each time I'm trying to connect. I
uh,
don't know.
okay, so the public key that you gave me was was tied with this private key.
I think so. No, actually, I changed this.
Okay, let me check it in real time. So SSH. So your account is Alvi. So cat. Okay, I can see. So can you show me your public key? Sharing public key is not a problem at all, right?
How do I show
But
it? I don't know.
maybe, I mean, it's fine. It's just us. So recording it will not be public, so it's probably fine. So so you have this mykey.pub. That's the public key, I think, right?
Yes, but
And mykey.ppk. That's the private key.
privately.
Oh, wait a
The
minute.
public.
Yes, okay. So to view this, go to the terminal. I usually just use the terminal. cat space the name of the public key. Okay, let me match it. So the key you have printed
I
now.
think this was the previous one. I
Yeah,
changed
this is
it
the
once.
previous key I can see in my list.
I was also having problem connecting with this key as well.
There should
I I previously thought this was the key I generated using the Putty, or I don't know how to spell it, Putty keygen for
yeah.
SSH using that. But I thought using that was a problem. I previously could connect to the server, but the problem I was facing is when I was trying to configure it in Visual Studio Code, I couldn't do it, unfortunately. I don't know what was the problem. That is why I changed it to the how do I say it? The local SSH of Linux that generated me another public key. I used that, and then I couldn't get connected to the server at all.
Okay. It's fine. We're gonna solve this. Like I have faced these issues many times, so hopefully we'll be able to solve it quickly.
Thing is, I'm actually not much familiar with Linux, and
That's
I'm
fine.
just
I mean, that's fine. You just so for example, the problem you are facing right now, if you kind of just save important information when you solve this problem, like কোন কোন কমান্ড ইউজ করে এই প্রবলেমটা সলভ করেছো বা কিভাবে সলভ করেছো, এটা যদি কোনো একটা ফাইলে জাস্ট নোট করে রাখো বা কোনো একটা ডকুমেন্টে, ফিউচারে সেম প্রবলেম ফেস করলে ইউ ডোন্ট নিড টু ডু এ গুগল সার্চ, রাইট? ইউ হ্যাভ অল এভরিথিং রিটেন ইন
yes,
লাইক কম্প্যাক্ট ফর্ম। So
exactly.
I try to do that. You guys should try to do that as well. Every time you fix a problem, make sure you have enough documentation on your personalized documentation for future
Keeping a
reference.
log file you mentioned
A
earlier.
log file, yes.
This is
Okay, so let's try to
now
solve this problem. So you want to connect to my server using the VirtualBox or using your main system?
uh, VirtualBox. I guess I don't have any Linux system. I
Okay,
told you earlier that I wanted to
okay, that's
install a
fine.
Linux operating system, but I couldn't.
Okay, that's fine. So which key you want to use? The first key you shared or the second key?
Since this is the first key which I have right now, I couldn't find the second key. So I think using this will be first
Okay.
procedure.
Run a command ls space la dash la, sorry. Enter.
I run this.
Yes. So it's listing everything, and you see there's a folder named .ssh, right?
Yes.
Uh,
The SSH keys, that folder I created, and the .ssh is the one I didn't create before.
yes, by default, the OpenSSH will look for configuration file and everything inside the .ssh folder, not any other folder. Okay, so
Okay.
you want to have your public and private key inside .ssh.
I see. How do I do that?
You can let's use the terminal. So from the terminal, uh, you can do, okay, let's do this. Do ls space .ssh lowercase, press enter just to see the content of that file. You see, inside that file, you have authorized keys, config, IDRSA, and public and private key, known host.
This was the idea as about I sent you this was the later one actually.
Second file,
The
okay?
later one is
Yeah, so we can use
I
the second
think
key, which is already inside that folder.
I think I should try again connecting with the second key since I know the name now. Let
Okay,
me try once
so
again.
yeah, try the command. Excuse me. Write down the command again, like here. Okay. So what's the
We
problem? One
can
ident file is not accessible. So okay. So what you can do on the keyboard, press up arrow. You have the same command and go to the first part. I mean ID underscore RSA text. There, write down after the dash I. Go there. Right after dash I. Yes. Here you write down dot SSH with a space slash ID underscore RSA. I mean, delete the spaces between like, yeah, yep, like that. Press enter. Uh, Bad configuration option. Why?
should we create another one in case?
Well, we can create, but the thing is, we need to solve this problem, right? Okay. Uh, a minute. Just a minute. I'm testing things on my own system before telling you the command. I don't want to confuse you. Yeah. Uh, okay, maybe it says there's a problem opening the file. Okay, go to .ssh folder, cd.ssh. The command is okay.
Inside this folder.
Okay, ls dash la space with a space, yes. And we see, all right, so let me. Yeah, this is perfectly fine configuration. So on the left, you can see there are some flags, RW, right? R means read,
Yes.
W means write. So you have read and write permission for user, like you as a user. Any user in your group or any other user don't have permissions, which is fine. Um, and here I see. Uh, okay, I have the file. Why should it doesn't work?
স্যার ওর এই ফোল্ডারে মনে হয় দুইটা প্রাইভেট কি আছে, ওইটা থেকে কনফ্লিক্ট করতে পারে।
Well, when you do it a private key, I see only one private key,
তো একটা দেখা যাচ্ছে।
right? ID underscore RSA is the private key, I think.
Yes, sir.
Yeah.
আরেকটা public, but দুইটা থাকলেও problem নাই because if they have unique names, it should be fine. Okay, so let's try this. Let's delete the old key just in case, like for example, যদি এরকম হয় যখন পাবলিক কি শেয়ার করেছো, that's one, I have it copied in my system, but at some point somehow you replaced only the private key, not the public key. যদি এরকম হয়, so for that case let's just delete id underscore RSA file. So the command is rm space id underscore RSA delete the space and write a star asterisk. Yeah, enter. That will delete all the files with the same name format. Run another ls, so you don't have any file. So now
That's
generate the public and private key using the what is the command? Keygen. SSH keygen. No, SSH dash keygen is a single command. Keygen. Enter. Write down the name of the key file.
Will it create a new one?
You can have the same name or new name is fine.
I think the new name will be better.
Okay. Just press enter.
I think I should keep it empty.
Okay. Do a ls.
Only ls.
Yes. And you see, you have ictp keys.pub. Can you send me that file or content of that file over Discord or something? Or you can email me.
Yes, I can do that.
Okay, quickly send it
Uh,
Discord or email me.
Thing is, as I'm using the virtual box connecting to Discord, it's a lot of time. Nevertheless, let's try.
ইমেল করতে পারো যেটা ফাস্টার হয় or there aren't any, I don't know. Oh, you don't have it logged in. Okay.
Uh,
Cat, you can use cat command if you want to copy the text, or if you want to upload the file directly, you can do drag and drop.
that's the productivity I don't know actually.
Control H to see the hidden folder. Yep. .sh.
Sorry.
এই উইন্ডোকে
Okay.
copy me, I don't know if it will work, it might. Did it work? Yeah, it worked. I can see the file.
Your mail, I forgot.
My mail is which mail did I share before? I remember. I think okay, let me send the mail address in Zoom, right?
This-
Let's try this.
The file is not uploading. Yeah, I should share the key directly.
You can to view the key cat, that file name. root.pub. Yep. Yeah, should be fine.
Send it.
Okay. Just a minute. Okay, I got the key. Uh, Let me add the key to the list. Uh, yeah, I have added the key. So now run the command to connect sh space dash I space the private key and other things.
Same
What?
thing.
This, okay. Can you open the config file? Cat nano config, nano space config. No, no, sorry. Just nano, not cat. So nano space config.
So Nano is the file editor for terminals,
Yes.
right?
So this is your configuration. Yeah, configuration looks okay. Can you change the identity file here?
How do I do that?
Here it says /home/ Dilawar dash alvi slash other things. Here you write delete
The new directory.
new file. Yeah, location of the new file. That will might work. Let's see. Slash the file name.
The public one or the private one?
Private one. And from on the first line, you have host and the IP address. You don't want that. You want host space a keyword like no, not there. Host name is fine. The host, not host name. Host name should be the IP address. Host should be a keyword that you'd be using.
Anything that I want to keep.
You could call it moment. That's the name of my server. Yeah. Now do Control O
Oh,
and enter.
done.
Control X to exit. Write SSH space moment. Enter. What? Could you go inside the config file again? Host identity file. Oh, for the identity file, you have wrong identity file word. Identity, I of the identity should be uppercase, and file, F of the file should be all uppercase as well. Identify file, nice. Identity file, TITY. Capital F. Now
Control O.
Control O to save, yes.
Control O, Control X.
Enter,
Or enter.
Control X. Now try SSH moment.
Connected.
Yep, see, that was the problem. It's wrong file name. So যেটা হয়েছিল ওখানে wrong configuration থাকার কারণে every time you ran SSH, it would read the file and it would know, okay, something is wrong. So অন্য command রানই হতো না।
See. So
Okay.
now, how do I just run anything?
Yeah, you can run
Let's
anything
suppose I
now.
want to run the SCF. I want to run the SCF file for Silicon. What do I do now?
You can do ls to see what's in there. Okay, to get started, can you go to the browser? I don't have much time now, so just quickly go to the GitHub repository.
Your GitHub repository.
Yes.
I think I cannot access it from there since mine is
You
Windows.
can just type GitHub. Search for a user. SHA314. Too many requests. This is the first request.
I don't know.
No, you don't need to sign in. Yeah, just go there. Jump to search or jump. Yeah, there. Just write SHA314. Enter. Okay. Go to on the left, there are users. The first user, yeah. And there you can find all my repository. Go to repository list, find Quantum Espresso, and go to code. No, don't open that. Go to code.
Yeah.
Yes. And GitHub CLI.
Copy.
Yeah, you can copy this. You don't have GitHub CLI, sorry. Try HTTPS. Copy. Go to the terminal. here just type git space clone space that address. Clone, CLONE, space the address. Yes, press enter. LS, okay, go inside Quantum dash Espresso folder, CD, Quantum Espresso. LS. Now you have all the files. You have Silicon file folder, right? Go to Silicon, CDSI, capital S, LS. You have PWTK file, you have input file. Go to input. LS. Yeah, you can run, now you
I
can run
see
this
that.
SCF computation here.
I see.
Okay. And
Thank you.
in my previous videos, I may have shown how to run like in server in details. You can always check that. And yeah,
I
in
think
my
I can
server,
run
try
now.
NP1 number process.
Yes. Okay.
Okay. Any other questions from anyone?
Thank you, sir. This has been a lot of help.
No problem. I mean, I
All
think we
together
should
at
have had
once
these
after
sessions
all these
before,
things.
right? I
Yes, that
kept,
was my bad, totally my bad. I have had things of my own, which is not an excuse at all, I think.
yeah, talk to me.
That was
If you have
totally my
problem,
bad.
talk to me. You have the, what do you call, Discord channel, right? You can post your
Yes.
errors, like talk to people. And that's really important.